are taking your own notes, so wherever you are taking notes, grab that. Today we are focusing on the sign of our trig function. Is it positive? Is it negative? Which quadrant does that mean for us? So we are actually going to jump to this page right here, determining the sign of the trig function in each of our quadrants. Because how you get into a quadrant never changes as far as the sign of the numbers in the ordered pair, we can already tell you which trig functions are positive and negative in each of those 4 quadrants. I'm going to build my way up to it because I don't want you to just like tell you, hey, this is how it is. So we're going to build our way up to it, but then we're going to get a little bit of a shortcut and say, okay, this is true always. How can I remember this in a way that I will be able to quickly identify if my trig value is positive or negative in each of our functions? This is a triangle drawn into all 4 of our quadrants. We're going to just zoom in on one quadrant at a time. So let's start with quadrant 1. To get into quadrant 1, we would use an ordered pair where it would be a positive x, positive y, or I move to the right, some positive number, up, some positive number, and remember your radius is always positive. Okay, well, I said all positive numbers, so it should make sense then as I set up the sign of our angle. It's some positive opposite over some positive radius, some positive y over positive r, which is a positive something, right? Same thing for your cosine. Some positive x adjacent value over a positive r hypotenuse value. A positive over a positive is some positive number. And same thing with our tangent. Quadrant 1 is easy. Everything's positive, and when I make ratios of positive numbers, everything turns out positive. So in quadrant 1, because when we get there is all positive numbers, every trig function that you do in quadrant 1 is also positive. It's as we move to our other quadrants that things aren't always positive. To get into quadrant 2, you have to move left, which is a negative x value, up, which is a positive y value, and again, your hypotenuse is always positive. So seeing how those fall into our 3 different trig functions, sine is your opposite, which is a y value, over your hypotenuse and r value. Those are both positive in quadrant 2, which means your sine value is positive in quadrant 2. Cosine is your adjacent, which is some negative x value over your hypotenuse. Well, a negative number divided by a positive is going to be negative. So all of our cosine answers in quadrant 2 are negative. Tangent is a negative opposite value. Oops, sorry, that's a positive. Positive y value over a negative adjacent value, which would be a negative answer. So the only thing that turned out positive in quadrant 2 was sine. Moving down into quadrant 3, we would have to move a negative x value, but then also move a negative y value, and again, a positive hypotenuse. So we would have, let's start with our sine value. Sine is opposite over hypotenuse, which is a negative y value over a positive hypotenuse. Sine is going to be negative. Cosine, a negative adjacent value over a positive hypotenuse, negative number. Tangent, negative opposite over negative adjacent, but a negative over a negative actually turns out positive. So we do get a positive trig value in quadrant 3, and that's your tangent value. And our last one, which is quadrant 4. To get to quadrant 4, we move to the right, which is a positive x value, down, which is a negative y value, and again, a positive hypotenuse. So setting up our trig functions, sine would be opposite, negative y value over positive radius is a negative number. Cosine would be our adjacent positive x value over our positive hypotenuse. Positive over positive is positive. And tangent is your negative opposite over positive adjacent, which would be negative. So as you step back and look at this, everything was positive here, but then they kind of took turns, right? One thing was positive in each of those other quadrants. So we can kind of sum it all up by identifying what's positive. Everything in quadrant 1. Sine's the only thing in quadrant 2. Tangent's the only thing positive in quadrant 3. And cosine's the only thing in quadrant 4. It is not practical for us to rebuild this every problem. So how are we going to remember this? Well, I have a little mnemonic device use it or not, but it has really helped me. And I draw a little coordinate plane here. And I put these letters out here, and I think you'll quickly be able to figure out what they stand for. A, S, T, C. What are those letters standing for? What's A stand for? All. Sine, tangent, cosine, and they are, what'd you say? Which ones are positive, right? It's showing us what's positive in that quadrant. All things are positive here. Sine only, tangent only, cosine only. Now, I said only, but remember, these are just the basic three. Sine and its reciprocal would actually be positive because they would use the same two numbers, right? So sine and cosecant, tangent and cotangent, cosine and secant. So that and its reciprocal. Now, great, but if I don't remember the order of those letters, it's not going to help me. I have a phrase, not a true phrase. However, it helps me remember the order of these, and you can pick whatever phrase you want or just draw it. I don't care. All students take Calc. So if I say that phrase, this is what I'm referring to. Think about your all students take Calc. That helps us identify, again, the order all students take Calc, that those letters go in, and it reminds me how to draw it, and now I can think through what's positive and what's negative. Make up your own phrase. It doesn't matter to me, but as long as you can remember what's positive in each quadrant, that'll help you. Okay? And that's our focus today. Using that to kind of help us get through where can our problem even exist in the coordinate plane based off of the given information. With that being said, you'll be told a lot of things are greater than 0 and less than 0, and we have seen this page over and over this year. Just a quick reminder again that if it says greater than 0, it means a positive number. If it says less than 0, it means a negative number, and we know that. We have seen this page multiple times this year. Okay? All right, so how do we attack the problems that we will see today, or that we are adding on today? We're going to see 3 of them, and that's it. And they're all going to look this exact same way. The secant of theta is the square root of 29 over 5. They'll give you 2 pieces of information. That's the first one. Second piece of information, sine of theta is greater than 0. Find the exact values, simplify your radicals, simplify your fractions, right? Exact values of the remaining 5 trig functions of theta. They give us 1. Secant of theta is the square root of 29 over 5. We're supposed to go find the other 5. Okay? Now we're going to do this the same way we've done this on all of these. We're going to work our way through, draw a triangle, label our sides, all of that. But the trick to this is we have to get our triangle drawn into the correct quadrant. So we use the 2 pieces of information they gave us to narrow it down to which quadrant that can happen in. They told us that the secant of theta is some number. Well, that number happens to be a positive number. Think about your basic 3 trig functions. Is secant the reciprocal of sine, cosine, or tangent? Cosine. So if secant's a positive number, that also tells me that cosine is a positive number, right? So as I think through my all students take Calc, I identify for myself, okay, which quadrants can this happen in? Well, all things are positive in quadrant 1. So our triangle could be in quadrant 1. Sine only, tangent only. Cosine is positive in quadrant 4. So right now I've narrowed it down to 2 quadrants. This triangle could be drawn into quadrant 1 or quadrant 4. The other piece of information they told us is that sine of theta is greater than 0. And greater than 0 means positive, right? So again, I identify for myself, where can that happen? Sine can be positive. Everything's positive in quadrant 1. And sine is also positive in quadrant 2. Once I've identified for that for myself, they will overlap in one of the quadrants, always. So which quadrant is that? All, in quadrant 1, right? They both work in quadrant 1, which means if I draw my triangle in quadrant 1, both of these things can be true. That's how I pick the quadrant to draw my triangle in, the place where they overlap. So let's do that. Draw a triangle into quadrant 1. Remember, start your pencil at the origin and trace your way to quadrant 1. Well, to get to quadrant 1, I would have to move right or left first, so to the right, and then up. I just got into quadrant 1, connect back to the origin, put theta at the origin. So our first addition, the new thing today, is the thought process on getting to the correct quadrant. Using the 2 pieces of information they gave us, all students take Calc to decide on which quadrant I'm drawing my triangle. Now I'm back to what I already know how to do. Use secant to label my triangle. Thinking about the fact that secant is the reciprocal of cosine, adjacent over hypotenuse, so secant is hypotenuse over adjacent. put that in my picture. So the hypotenuse is the square root of 29. My adjacent is 5. Now, I know this triangle is drawn into quadrant 1, but at this point, you always need to pause and say, do I need to make any of those numbers negative? Okay, well, I moved to the right, so that should be positive. This is the hypotenuse, always positive. So we don't need to adjust any of that, but we would want to always at that moment stop and just make sure I don't need to make any of them negative. Okay? Pythagorean theorem to find our third side, like always. What is the square root of 29 squared? 29. Okay, and it is true that when I square root something, I do get plus or minus, right? So y could be positive or negative 2. But specific to this problem, which one would we pick? Positive, right? Because it's moving up. So that's how I know that this should be the positive 2. And again, as you guys are doing this, especially we'll see on the next 2 examples, never go by the fraction itself. Put your numbers in the triangle and then say, did I move right, left, up, or down? What do I make positive? What do I make negative? Go with the picture, not the fraction. Okay? And then we set up the rest of our trig functions. And that you guys know how to do. So I'm going to let you guys do that. Go ahead and set up your other 5, and then I will get answers from you in just a second. Brogan, I'll take sign when you've got that. Cole, I'll take cosecant when you've got that.
5 squared 29. Oh, cosecant.
Which did you just give me cosine? You go ahead and say that one again.
5 squared square root of 29.
Seth, I'll take cosecant from you, and Alex Roberts, how about tangent from you, and Alana, I'll take cotangent when you guys are ready. And everyone at home, you guys are checking answers, right? Oh, sorry, go ahead. Good fix. And Seth, are you my... Okay. Now you guys are all my teachers checking the answers. How'd they do? Any of them that we need to fix? No? All right. Questions? So let's recap what we just learned. This is new, right? Using this to make a decision on which quadrant to draw our triangle into. But once we made that decision and got our triangle drawn, from there, labeling, Pythagorean theorem, that stuff, all we've already done. So adding just a little bit today. And we'll see kind of the different variations here. It can't change much, but there is some good conversation to have on this next one. The difference on this one, the 2 pieces of information they give us. Cosecant of theta is -3. So again, we already have one of our 6 answers. Cosecant of theta is -3. They say that tangent of theta is less than 0. Same directions, find the exact values of the remaining 5 trig functions. Your job is right now to figure out which quadrant we are going to draw that triangle into. So I want you to use the 2 pieces of information, think through your all students take calc, and decide. Now before you get too far, let's make sure that we've got the right quadrant and the right third side before we move on to our actual answers. Take one piece of information at a time. What quadrants can that be in? It will always be 2. Take the other piece of information. Which 2 quadrants could that happen in? Where's the overlap? Dylan, cosecant is a reciprocal of which one? So they're telling us that sine can be negative, right? Or that sine should be negative. Kenzie, which 2 quadrants can that happen in? If sine's negative. Yeah, 3 and 4. Everything's positive here, so that's not it. Sine is positive here. So if it's negative, it could happen in quadrant 3 or it could happen in quadrant 4. Our other piece of information, tangent of theta is less than 0. What we talked about at the beginning, less than 0. So we're kind of thinking backwards this time. Instead of where it's positive, it's where it's negative, right? Let's go Nick Wageman. What quadrants, which 2 quadrants could tangent be negative in? Quadrant 2 and quadrant 4, right? So we see the overlap, yes? The place where both work would be quadrant 4. So we will draw our triangle into quadrant 4. Start at your origin. To get to quadrant 4, I would need to move to the right and down. And once I've gotten my pen into quadrant 4, I connect back to my origin, put your angle at your origin. Now, this is the first time that our problem had added something a little unique, and that is that our ratio is one number. Okay? I need it to be a ratio. How do I fix that? Over 1, right? Now, here's the other thing that's a little unique on this one. Cosecant is supposed to be the reciprocal of sine, as we discussed over there. And sine is opposite over hypotenuse, so cosecant would be my hypotenuse over opposite. Now here's what I was talking about earlier. If I follow what I have written up there, I would put these numbers in my picture. There are 2 problems with what I just wrote up there. Does anyone see what they are? Hypotenuse can't be negative, and the 1 needs to be negative. So this is the discussion of, in a fraction, if you have a negative, that negative can float anywhere in the fraction, as long as there's just one of them. So it could be out there, it could be out front, it could be on the 1, which is actually where that should have been. So my strong suggestion is I will never put the signs that come from my fraction. I put them in my picture and I just think, did I move right, left, up, or down? Okay, always. I don't take it from my fraction. I put them in my picture and I think about which direction I moved. Do I need to change any of the signs? All right? Pythagorean theorem to find our third side. We've run into this just recently, right? Square root of 8 does simplify. Square root of 4 is 2. We, on that side, are moving to the right, so I would pick to use the positive version of that number. Square root of 2 over 2. All right, now, questions so far? From there, I'm pretty confident with how we can get our 6 trig functions, but any questions up to that point? Okay, go ahead and set up your missing 5 trig functions. If you need help with your neighbor or whatever, I will give you a couple minutes to do that, and then we'll get answers on the board. Make sure we simplify. right, we'll start getting some answers up here. Jared, when you're ready, I'll take sine from you. Kaylin, how about cosine? Jonathan, secant, when you're ready. Jordan, I'll take tangent when you're ready, and Peyton, cotangent. I feel like you might have given me cotangent. Is that what you had for cotangent? Okay. My checkers, how we doing? Good. I feel like there's one we need to adjust. Does anyone find it? Yeah, it's the. Yeah, if we go back to the unsimplified version of it, that was correct as far as how we get this radical 2 in the top. But it's -1 over 2 square root of 2. This is super common when I do my rationalizing, is we lose the number in front, but that's still there. The square root of 2 times itself is 2, times the 2 that was sitting in front of it would actually give us a 4 in the bottom here. I think the rest are good. Remember that these are reciprocals of each other, so your signs should match between the angle and the reciprocal of it, right? Like our tangent and our cotangent shouldn't have opposite signs ever. Okay, any questions for me? We're gonna do one more. Hopefully this one kind of all on our own. So 2 pieces of information at the top. Tangent of theta is -1, sine of theta is greater than 0. Use your combination of those two to think through. All students take calc. Which quadrant can you draw your triangle into? Start there. If you'd like me to check your quadrant before you get too far into the problem, I would love to do that for you. It's not. Tangent's negative there, but sine is not positive there. Sine's positive in 1 and 2. Okay. All right, a lot of you had me check your quadrants, and we're doing a nice job on that. Let's make sure that we're all on the same page here. First piece of information, tangent is a negative number. So thinking through, again, kind of backwards. Where can tangent be negative is where it's not positive, right? Tangent's positive in quadrant 1 because everything's positive in quadrant 1. Tangent's also positive in quadrant 3. It is not positive. It is negative in quadrants 2 and 4. So there's what I've narrowed it down to. The other piece of information is that sine of theta is greater than 0, which is positive. The places that sine can be positive, everything's positive in quadrant 1 and in our sine-only quadrant. The overlap happens in quadrant 2. So we should draw our triangle into quadrant 2. To get to quadrant 2, I start at the origin, I move left and up, connect back to the origin. Use the piece of information they gave me. Again, this time, just like on the last page, it's not a fraction, so I make it look like a fraction. Tangent is our opposite over adjacent. I would again stress the don't put signs in from the fraction into your picture. My numbers are 1 and 1, and then I just look at the picture and say, okay, which directions am I moving? Left should be negative. Up should be positive. So actually, if I went back to my fraction, that negative kind of came from the bottom one, not the top one. Okay. Pythagorean theorem to find our third side. Again, we do get the plus or minus square root of 2, but it's the hypotenuse. Hypotenuses are always positive, so I'll put positive square root of 2 in my picture. We'll pick up there. Give you another second to think ahead of me here to get your other 5 trig functions. Michael, when you've got sine, I'll take that. Nick Peterson, I'll take cosecant. Lily, cosine. Sailor, secant. When you guys are ready. Did I give you secant? I would check it again. And Jude, have I heard from you today?
No.
How about cotangent? I forget. I gave you cosine, right? And I gave you cosecant. It's all right. But then we can simplify the 2's, right? That one is ugly. Yeah, our sine one should be positive. Okay, lots of little places to make mistakes, which is why, again, it takes a lot of practice working our way through all of this. Biggest thing I want you to get out of today's stuff, getting to the correct quadrant. How do we draw a triangle into that quadrant? Any questions for me? All right. Your assignment is out of the book.